Hello everybody, this is Building an EmPyre with Python. Just want to say I love B-Sides Las Vegas. I spoke here last year on PowerShell EmPyre. We know the names get a little weird. We'll explain that at the end. But I love this conference. I love interacting with everybody and super stoked to be here again. So my name is Will Schrader. I don't know if anyone was in the 2 o'clock talk for Bloodhound, but I'll be brief. My handle is Harmjoy. I'm a researcher and red teamer for the Adaptive Threat Division of Verisk Group. I've done a lot of offensive PowerShell, but this will be one of the first talks in a bit that I will not say the word PowerShell the entire time. So if you're tired of hearing me say that, you should hopefully be happy. I'm a co-founder of a few projects and active developer, the Veil framework, PowerShell EmPyre, and this project. I'm also a PowerShell MVP and an active PowerSploit developer.
Riding on Will's coattails. I'm Steve Borsch, Verisk Group. Prior U.S. Army infantryman. Kind of did a career change a few years ago. Decided to go from kicking indoors to breaking into security systems. So I've also authored some tools, worked on egress assess, EmPyre, some things like that, and PowerShell EmPyre as well.
My name is Alex Rumdeco Harvey. It is a mouthful for sure. My handle is KillSwitchGUI. I work for Verisk Group as well. I'm a pen tester, red teamer, just like these guys are. And a few things I've helped work on were Simply Email and Simply Template.
Cool. All right. That's all out of the way. So what we're going to be talking about today. So I'm going to go a bit over the motivation for building this project, and in 5 seconds or 10 seconds, Python EmPyre is an OS X and Linux-based malware agent that has a very similar architecture to the PowerShell EmPyre project. We're going to go over the background of EmPyre, the architectural decisions, like kind of RATS 101, like why we built it this way. Go over some of the stagers with Steve, host and network triage with Steve and Alex, lateral movement, persistence, and the like, and really kind of go over how this agent can facilitate the tradecraft that you might be used to on Windows, but do it instead for OS X specifically, but also a bit for Linux. It's going to be an ongoing theme throughout the entire presentation. I'll make a few comments at the end of kind of about future plans, combination of the code bases and things like that. And all throughout the presentation, we're going to have like small demos. Instead of one 10-minute demo at the end, we're going to break it up into like little 2 or 3 minute chunks, so you don't have to hear us just talk through slides the entire time. So why build this? So we do a lot of engagements. We do a lot of pen tests. We do a lot of red teams, which we kind of define as 3 to 6 week type engagements. We had a particular client or a couple of clients that started having more heavy concentrations of OS X machines in their environment. And this one particular client, they were like, well, come in, do this engagement. We did the first engagement. We essentially tried to hit all of the Windows virtual machines and developers and things like that, because we're really heavy Windows tradecraft. We hit that, and we went back. They were like super happy, and afterwards they're like, well, okay, we're going to bring you in again, but you have to hit OS X. It was late last year. And we're like, oh shit, OS X, okay. We know a couple of things, but there's not nearly as much information on OS X as there is on Windows, right? It has a much smaller market share, so there's not as many attack tool sets. There's a few small pieces. FuzzyNop did a great presentation in 2014, DerbyCon, if anyone saw it. I think it was Red Teaming Back and Forth 5 where he talked about some of these OS X, PostX kind of capabilities specifically. But we didn't really see any kind of complete OS X agents, right? There weren't a huge amount of possibilities for us. So over Christmas last year, I spent the entire break, rewrote a Python malware agent for this particular client. And instead of writing it from scratch, I don't know Objective-C, Swift, whatever for OS X. I'm a Windows dude. So I was like, okay, there's Ruby and Python and scripting languages. Like, okay, I'm just going to go with the PowerShell EmPyre type architecture. We use a huge amount of the kind of the back-end PowerShell EmPyre controller, which we'll go over here in a bit. And, some of the stuff that's out there for OS X, so even though the pen testing community does not have as many tool sets, there is obviously malicious OS X malware out there, right? WireLurker for Trojanized applications, Xcode Ghost for Xcode packages, kind of originating from China. Hacking Team with the leak and all their source code, we got a really nice kind of view into these more advanced almost nation-state style OSX tools. This is not nearly as good as that, obviously, because we're just a couple of dudes doing this in our spare time. But again, there has been malicious OSX tool sets out there, but there hadn't been something super open source and public and with a modular architecture that we're used to operating in as open source legitimate pen testers and red teamers. We're gonna touch on this throughout the entire presentation, but OSX, to us at least, presents a good number of challenges versus Windows. There aren't nearly as many public OSX attack toolsets because of the market share. In particular, there's a few things that are really kind of pain points for us for OSX from a pen tester perspective. Initial access vectors there's just not that many of them. With Windows, you have HTAs and macros and like the reg SCT type stuff. You know, it seems like every few weeks there's a new access vector you can have for Windows initial access through phishing. For OSX, we didn't really see many vectors like at all. So we ended up kind of creating a macro-based approach, which afterwards some people came out of the woodwork and like, oh yeah, this has been public, but it just wasn't publicized. So we're not claiming we invented this stuff. We're just trying to develop solutions on the fly for engagement so we could be effective. Lateral spread is also really annoying for us. If you're Windows, you have pass the hash and all this really fun stuff and domain delegated access. With OSX, you might have SSH, you might not. But other than that, it's a lot more difficult for sure, and Steve will cover some of that stuff in a later section. So Bratz 101, just a few of the kind of thoughts we had when we started designing the architecture of this whole project. So we want staging flexibility, and by that we mean we want an easy way to generate a large number of stagers. Stagers, I mean the first little bit of code that's executed on a system that starts the staging process for the entire rat. With EmPyre, or Python EmPyre as well as PowerShell EmPyre, we don't give you, unless you really want to, the entire rat in one malicious block. We have like key exchange and all this type of stuff, so you can run just a small little one-liner snippet in a variety of ways to get the entire agent staged into memory. Modularity, just like the PowerShell EmPyre project, we want to give people the ability to build their own modules. And actually, the talk right after this, they're dropping some live Python EmPyre modules. I haven't seen them at all. They developed some awesome stuff. I don't actually know the contents of the modules they're dropping, so we're pretty excited. And also, we care a lot about crypto. We don't want self-signed SSL certificates to be the only thing that protects the communications for our clients' environments. And these really high security clients, they care about crypto as well. So if we can demo to them, like, look, we have encrypted key exchange, perfect forward secrecy, and all this stuff to show that we thought through it, hopefully that makes them a bit more at ease. And also, I'll touch just briefly on the staging problem. Somehow, your malicious code has to get to the target. Whether you package it all up and send it to them, in one initial payload, you can do that. But somehow, this code has to traverse the network to get to the client. So there's a lot of things that kind of come into play with that. So the solution we built, Python EmPyre. That was our last minute, now slightly regrettable naming scheme because everyone's like, EmPyre, like what the hell are you talking about? But we thought it was clever at the time and kind of a sleep-deprived and caffeine-fueled end of the development cycle. This is the interface. Just to kind of show you guys, it should look very familiar to PowerShell EmPyre because it uses 95% of the same backend code base. It's a text-based driven tool. We also have a RESTful API, which I'll touch in kind of right at the end, where people have started to build front-end GUIs for these types of tool sets that we're building because a RESTful API provides the ability to do so. So we're excited about the future possibilities. If anyone wants to talk about that later, we'll be out for a little bit in the main room and we'd love to talk shop. So the background, again, Python, pure Python-based agent. It's Python 2.7 and 2.6 compatible, so it'll work on most Linux systems, and it will definitely work on OSX systems. This isn't just a POC tool that we developed a couple months ago. We used this on engagements more than once. It's been extremely effective for us, so we're happy to share it with everybody. And heavily based on the PowerShell EmPyre project. It has an asynchronous communication model, so the client will request a tasking over HTTP or HTTPS. At the moment, we're hoping to incorporate more transport mechanisms in the future. the server returns an encrypted blob, but with this, instead of an established type of connection that's kept persistent, this is all asynchronous. So reach out, get the tasking, process it, post the results back, and you can have delay intervals anywhere from 5 seconds to hours. We have asynchronous, and we also have Diffie-Hellman-based encrypted key exchange. I won't go into all the guts of this stuff. I find it really fascinating, but I know most people don't. The point with this is Diffie-Hellman EKE gives us perfect forward secrecy with a different session key per client. So if incident responders image a particular box and pull out the key, they can decrypt that client's communications, but they cannot decrypt any other agent communications they see in their network. I think EKE is awesome. And we have a variety of post-exploitation modules, some of which we'll be covering during the presentation in depth. Module development, just like PowerShell EmPyre, the development for this project is extremely quick due to the modular structure and the use of a scripting language. So instead of having something completely compiled and you're like, I want to modify X, you have to go through Xcode and recompile all this stuff, and it gets pretty difficult with binary code. It's a scripting language. It's just Python. So if you want to extend something in the field, which we've done several times, it's really easy to do so if you know what you're doing. Modules here are essentially metadata containers for an embedded Python script, just like PowerShell EmPyre. And we have nice little options like whether or not the module needs administrative access with sudo, whether it's OPSEC safe, which we care about a lot, meaning does it drop a file to disk or display something to the user, whether or not you want to save file output to a particular format when the results are kind of sent back. And it was really kind of fun designing our own rat and building all the little things into it that we always wanted, like kill dates, working hours, like all those nice little options. Cool. So Steve is going to talk about some of the stagers' initial phishing access.
All right, thanks, Will. So stagers, Will talked about getting our initial malicious code execution on the target host. So that's what we're going to talk about here. The first stager that we built for operating on some of our clients were the macros. Typically, we think about Windows when we think about Office macros. Well, we can do the same thing for OS X targets as well. Microsoft and OS X have Office in them as well. But we have to change how the macro works a little bit, and we'll talk about that. So this blob of text right here is a generated macro that EmPyre creates. You give it the listener where it's going to call back to, and it generates this blob. This is the actual macro that you stick in the Office document that you're going to send to the target. It's kind of hard to see down here, but at the bottom, it's actually calling Python. It's taken this entire base64 encoded blob, echoing it to Python. And the reason we echo to Python is that way incident responders can't see the agent running as a process in memory. They just see Python. We found out during development that just calling Python to decode the base64 encrypted blob actually showed the entire string of the agent in memory. So we got away from that.
Yeah, so you would have Python-C equivalent to like PowerShell-encoded command or -C. But if you just echo components to a Python binary, it accepts anything on standard in as code and executes it.
Thanks, Will. Echo binaries, mock object file format for executables. So Windows, we have executables. We can execute batch files. We can execute HTAs, a whole other range of executable formats. This is what we use for OS X. And what we do is we hot patch a binary with the EmPyre stager. It actually includes the entire Python library interpreter. We use that actually on engagements. Client can have like Casper, Jamf, and they can push our binary out to the target machines if they don't actually want to go through a phishing exercise. You can just push it out, execute it on the remote system, and get your callback. We also have dilib hijacking. Much like DLL hijacking in Windows, this research was based off of Patrick Wardle. He has a great PDF right there all about it. I won't get into the details too much because it's a bit complicated, but it's basically abusing search order loading. If a program wants to load a dilib or like DLL, it has to go in an order of directories to find that, and we can abuse that. We also use this as a method of persistence in EmPyre. This is the hijack scanner module. This was also based off of Patrick Wardle. What this does is it scans, much like if you've used PowerUp in Windows, it scans for possible hijack locations. You have RPath, which load order hijacking like DLLs in Windows. We also can look for weak dilibs, which means that that dilib doesn't actually exist in the directory. Then if we create one, put it in that directory, when that program is launched, it'll launch our stager instead. So we can find the hijackable point, and then with EmPyre we can create a hijack module, run it on the target system, and when that is executed, we get our callback. So at the top here, you see a little bit of green text. It's kind of fuzzy, I'm sorry about that, but that's the actual agent coming back. What we did in this case, we installed Xcode on the target system, and Xcode by default has a weak dilib problem, so we're able to hijack that. When the user double clicks on Xcode and launches the program, it launches our stager and then launches Xcode. And
Cool.
Will's going to spool up a quick demo on phishing with Office macro.
I think that's pretty cool. We have, you guys probably won't be able to hear it, but, oh, one second. Okay, here we go. I know the text is a little bit small, but okay, we're starting up Python EmPyre. We're going to create a listener. Just like PowerShell EmPyre, you have your working hours, default delay, redirection, loss limit, those types of things. These options are what are patched into the initial agent as soon as an agent is staged from this particular listener. We're going to create a macro for this listener. This is
Oh. Just want to talk about,
Okay.
so an option right here, set little snitch to false. On an engagement, we found out that some of our target users were using little snitch, and that actually got us burned because we launched our agent on the remote system. As soon as it tried to call out, it alerted the user that our agent was calling out through Python, and they alerted their IR team. So what we found out was that a lot of the developers don't use little snitch, and we entered in an option to turn that check off. So it checks to see if little snitch is running. If little snitch is running, the agent just dies, and it won't call back.
Yep,
That
pretty
way,
useful.
if we're on a red team and we're trying to be stealthy, we can get by that protection.
Again, that is not an exploit of little snitch. It's just a check and then killing the agent. It keeps it from staging. So here we're going to take that macro, paste it into an Excel notebook. I'll speed up just a little bit in the interest of time. You know, paste it into, just like Windows, right? Paste it in. You see what's echoed to Python. I'm going to open this, click Enable Macros, because I totally trust this whatever totally not phishing email that I sent myself. And at that moment, as soon as that Enable Macros is clicked, an agent will be staged. That was kind of cool. Macros are not just a Windows problem. Cool. Now, Alex is going to talk a bit about host triage.
Appreciate it. Just like on the Windows side, the first things we generally go through are some type of situational awareness, maybe some host surveying scripts. So we're going to get into that part. Obviously, one of the first things that generally take place on an engagement after doing some basic situational awareness is we want to know if we can escalate. There's specific modules within EmPyre that are obviously going to require an elevated context. So on the Mac side, you're not going to see as many, let's say, privilege escalation vulnerabilities out there. And if they are, they're generally updated pretty decently fast. So just like on the Windows side, on our tradecraft where we generally have to either find passwords, maybe GPP, or some other type of like share or logon script, or any type of like escalation method we can go through using PowerUp. We would see the same kind of methodology applied on the OS X side. I don't know how many OS X users are out here or Mac users, but on just a show of hands, how many of you guys actually run as admin on your OS X box? Okay, so few out there. Some people do separate privilege, privilege separation properly, some don't. On the development side, as developers, obviously in an organization where you're installing, pushing code, and doing these types of activities, you would often see users as a local admin. So that kind of gives us somewhere to start with. In this case, we have 2 different ways that we're actually going to talk on. There's a few different privilege escalation checks you can go through, but 2 that have been really successful for us are prompting. In OS script, you can actually call an application to prompt a box. So we've used this method in live engagements to gather credentials. So the first one is the Mac app prompting, so you can tell let's say the App Store to open up an application saying, hey, I need your password. Please trust me and give it to me. The second one that we came up with was the alley-oop method. Just like on Windows where you can pump a UAC bypass, you could do this same exact method, but there's an interesting caveat to this. On the OS X side, there's a tool called security. With the security tool, you can force an unlock of the keychain. So using this method, you can prompt the screensaver, force the user to go to the screensaver, not allow them to exit out, take the password, check it against the keychain. If it doesn't unlock, you're not going to get through. It'll say, please enter your password correctly. If you do enter it correctly, it will unlock the keychain, and the logic will basically allow you to log back into the Windows box, back into the OS X box. So that's kind of mean. Definitely not OPSEC safe, but you can gather credentials this way in an evil fashion. And once those credentials are gathered, just like you would potentially elevate on the Windows side, you could do the same thing with the pseudospawn to get a root context agent. So here's a horrible screenshots that just sadly didn't come in well. But at the top, you're basically, you can actually see right at the top, it actually tells you the text return was password 1234. That was with the basic one. And then actually on this, we'll see in the demo as well, we see 2 bad passwords entered and then obviously the correct password, which unlocked the keychain. And that's just kind of a small example of that taking place. So once you have your password, generally, developers are inside an internal environment. They might have tons of different resources that they have access to. They might have a password for Citrix, and they might have a password for an employee portal that we need to get access to. They usually use some type of password storage. It's too easy to just use the built-in keychain. Unfortunately, that built-in keychain originally had some issues with where it stored the master key in memory. So we actually ported over, we'll port it over a full port of it from C, and was actually able to implement in Python, and we're basically able to decrypt the key store in memory using Yoso's POC code, which is really cool, but it only applies to OS X Yosemite. So that's kind of like a hard point. So while most of us update as normal users, as you would see in a Windows environment, you're still seeing people in Windows 7, let alone you're still possibly seeing Windows XP boxes out there. So while you would think as a normal OS X user, you might be upgrading on a consistent basis and this might not apply to you, we will still see this. And the next one would be the keychain dump or chain breaker. We actually did a full port of that as well. That allows for a master password or just a standard password that you gathered, and you're able to basically dump the entire keychain right inside the agent in memory. The next thing, obviously, hash dumping. While on the OS X side, the hashes are quite strong, they use quite a cipher to basically build this hash, and it could take some time, but we do get lucky. And one reason why you would want to do a hash dump is in a corporate environment, you may see built-in accounts that basically are used for remote administration. And we'll talk a little bit about this more on the SSH side. Just a quick example of us just dumping some hashes in the hashcat ready format so you can easily crack them. Just as on the Windows side, I'm sure a lot of you have used the capability of key logging. It's fruitful. We generally can collect a ton of information, whether it be passwords in the background, just keep it rolling as the agent's going all day. You can gather all types of information that may be able to help you in post-exploitation, or potentially gather credentials, like let's say from a PuTTY session or something of the sort. And this actually is implemented from the MSF side and is a full port, and it actually uses Ruby. Hopefully in the future, we'll be making a progression to move it to a full Python version. And of course, our screenshots. Definitely helpful for identifying what the user's up to for situational awareness methods. Quick note, we do support 2 different screenshot modules. We'll talk about that in a second. The first one is the native, this built-in screenshot tool, which is a command line option which will output to a file. And then we also use a pure Python version of it using the Quartz APIs call, which is implemented in Python. So,
Still make the sound?
say again?
Still make the shutter sound?
Which one?
With the native? Either.
I actually don't know that answer to that one. I would have to get back with you, so I would not be giving you correct false information. But every time I've done it, I've never got the sound. As I was saying before, the environment can dictate heavily on what tool set you use. If you're in an environment like we've seen before with Carbon Black, with Hipson devices, they will catch these built-in methods, and you could potentially get flagged very easily in an environment that's potentially being monitored. So that's something that you have to identify in the beginning of the host survey of what tool sets that you're willing to use so you don't make the mistake of using the built-in screenshot as well as PB copy for a clipboard. And this actually leads us into clipboard theft, a really solid way of potentially grabbing passwords from, let's say, like a LastPass instance where they're using copy and paste consistently. Cool thing about this is you can basically set it up on a timed interval, let it run for about an hour, and you can gather all the credentials that you need while they're doing the work. And this is also, like I mentioned before, this could also be signatured from the PB copy command line version. Just a small example of it actually taking place in just different timestamps.
Cool.
All right, demo time.
Yeah. Now we're going to do, Alex is going to talk through a quick demo on host-based collection.
Yeah, so we're just going to go through a few of the 3 of the actual things we just talked about. Just like I want to actually show you this one because it's quite interesting, which is the screensaver alley-oop. I'm actually just going to set this to a small X account, which you can specify so you don't force the user to consistently go for 15 times straight, depending on what you would feel comfortable doing. As you can see, it actually brings up the screensaver to the person. It's not the same exact login prompt, but it may trick them, but it will definitely force them to potentially give you their credentials. It does lock the keychain. So when the user comes back in, for any application using that keychain, they may actually have to go back and unlock the keychain. Once credentials are actually gathered, just for the sake of time, I actually removed the sudo spawn, but I'm actually changing my agent over to a different agent that's on my secondary box, and I'm actually going to use a collection module for gathering for the keychain that we talked about before. In this case, it's a 10.11 OSX instance, so I'm not going to use the keychain dump, but I'm using the chain breaker module, which allows me to dump the passwords basically forensically sound target side.
And again, with that, the general tradecraft is prompt the user for the password, use that to then respawn a high integrity or sudo agent, so you can do the interesting post-exploitation options or effects like hash dumping.
So in a second here, we should hopefully get some credentials back.
Can you see the OPSEC check? So we're doing things that may or may not prompt the user or modify the system, so it's just a nice little reminder.
Once it comes back, it should spit out all the actual private keys, certificates, passwords, the whole shebang. And this actually works for not only the login keychain, but also the system keychain for messages, for the iMessage and Yahoo accounts and all that stuff. So that's quite cool capability of this. Once passwords are gathered, we know we have a proper password. Remember, if you do a sudo spawn and you mess up the password, you could potentially be flagging. So just keep that in mind. So I'd like to actually test this.
Not that any of us have ever done that.
That's a really cool thing about the keychain is you can actually test it against the keychain, and it does generate a log, but it's not generally signatured on. And this is actually just a quick hash dump like we talked about before, outputting. And this is actually the end of the demo.
Cool.
You're up next.
So with that hash dump, what we did on a client engagement was dump the hashes, crack the password, and since it's in a corporate environment, they use the same password and had SSH enabled on all of the hosts. So we were then able to laterally spread to every host. We could get into network situational awareness. What do we do once we're on the host? What's around us? What can we see? What can we do? And yes, OSX is on the domain too. In our engagements, we found that admins need to admin. They need to enforce corporate policy, be a group policy. They have to manage their resources, their users, objects, advertise resources such as printers. And they benefit from the single sign-on access to Active Directory through Kerberos. It's pretty easy to set up. I'm just showing a picture of the directory utility in OSX and how it attaches to the domain. You see the option for allow administration by. Typically, it's domain admins and enterprise admins. If you found other users in there, maybe you could start targeting them. OSX and LDAP. OSX has and most Linux distributions have a tool built in called LDAP search. This is what we use in EmPyre to bind to Active Directory and then perform the search that we're trying to do and get the data back. This bottom line here is just a quick way to find out where the domain controller is or LDAP server is in the network. So how many people have used PowerView? PowerShell, PowerView. Awesome. Good to see. You guys don't count. You're all on our team. So we wanted to port some of those features of PowerView over to the EmPyre Python version as well. Because even though we're operating in an OSX environment, Active Directory can provide us with a lot of information, perhaps what computers to target next, what users to target next. We talked about Bloodhound finding paths. So we're going to go along that route to find our next targets with a PowerView style. Unfortunately, there's a caveat to this. It does create a logon entry in Event Viewer for every time an LDAP connection connects to Active Directory. Some of the things we ported over: get computers, tell us what computers are on the network, what domain controllers are on the network. Our file servers, those might be good places to hide because they have high uptime. Group memberships, group members, what groups are out there. A lot of times stuff are nested in OUs. Get user information actually just grabs all of the information for a specific user, and we can list out all of the users in Active Directory as well. One thing that we found that we haven't been able to do yet is enumerate session data remotely from OSX. So unlike if you saw the Bloodhound stuff earlier where we could figure out who's logged in where, we don't have that ability in EmPyre right now. If any of you know how to do that, come see me. So this is a shot of PowerView OSX style. Basically, we're doing a situational awareness, trying to get the computers that are in Active Directory. We set our bind name. This time we're going to use the user jfrank@hackme.com. Of course, he's a manager, so his password is management for life. And the LDAP address, that's a domain controller. We're going to execute, and it pops out just a nice list of all of the computer objects that are in Active Directory, all from OSX. Overpass the hash. This is some pretty slick research done by Gentil Kiwi and ObscureSec. And then we ported that over a tweet from the guy passing the hash. He actually did this in OSX, and then we figured out we can port this into our EmPyre. Basically what this allows us to do is if we grab hashes on the domain, we can upgrade those to Kerberos tickets and then authenticate in anywhere in the domain with that hash without having the password. Some of the utilities that are with Kerberos are KInit, KList on the target to see what Kerberos credentials exist on that target. And then you can use KDestroy if we want to remove any credentials from the target site. Ouch. All right, this fuzzy blob is overpass the hash. Basically, we have NT hash that we found on the network. We run overpass the hash. It generates us a Kerberos ticket, and then we can LS the domain controller.
Cool. Now Steve is going to talk through a cool little demo with some domain enumeration. This will be the last demo for the talk.
So we've got our EmPyre server running. We've got one listener, one agent currently active. You can see it's on a Mac box, internal IP address. The user, J. Frank. We're going to use a module to pull out, pulling out here, get OUs, I believe. So there's a list. If you tab complete through here, everything is tab completable. It'll list what's next. We're going to do group members because we're going to find who the domain admins are. We want to know where our domain admins are so we can start targeting them. Enter our authentication stuff to bind with LDAP search. Execute, and then it pulls back all the users of the domain administrator group.
All from OSX, which is pretty cool. Now I think it's the OUs.
Now we're going to get on to enumerating OUs. A lot of times there's some juicy information in there. All right, good. Thought we were wigging out. Same thing, we want to use module. It's tab completable. We start typing situational awareness, tab complete out, and pull out information for the OUs in the Active Directory schema. So now we have an OU for domain controllers, 2 service account OUs, and the IT admin OUs. So then we can take that information and perhaps start enumerating further to gain some more situational awareness on where we want to go next in the network. Still me. All right, cool. Lateral movement. We started this off by prefacing that lateral movement is hard on the OSX side or in Linux side. Windows, we have great tools like pass the hash, WMI, we can psexec, WinRM if it's enabled. We can remote desktop and just log right in if we need to. OSX disappoints us a lot on this front. There's typically SSH, and for most standalone systems, SSH is disabled by default. I know a lot of you are nodding your heads on that one. But in a corporate environment, admin's got an admin, so they typically have SSH enabled. There is a WinExe package through Homebrew, but on a client engagement, we're not going to install stuff and enter more vulnerable services on a target host if we can keep from it. So it would be nice if we can port this over. We've been working on it, but haven't had any success yet to have a WinExe type thing to do pass the hash on the OSX side. Hopefully we'll have that in the future. We do have EmPyre modules. We actually have an SSH launcher module. So what it'll do is authenticate to the remote system. It'll run Python in memory with our launcher string, call back, grab our stager, and execute it in memory on the remote host. We also have an SSH command where we can run a command on the remote system and then just get the output back. So if you just wanted to check kernel version, do uname tac A or something like that, you could run that and then get the information back all through EmPyre. Web service exploitation, we've actually used this to pivot to the Windows side from the OSX side. One example of that is to exploit JBoss, my favorite thing ever. And we can pass that exploit to an EmPyre server, PowerShell EmPyre. So up here we've loaded up the JBoss exploit module. And what that does is abuses the JBoss flaw in the JMX invoker servlet. And instead of executing Python on the remote system because it's running Windows, it executes our stager that we loaded up for PowerShell EmPyre, and we get a callback and now have pivoted to the Windows side. So we're starting to get into mixed environments, and we'll talk about that a little bit at the end and what we're going to do to fix that problem. There you go. Staying on the box.
Yep. So the next obvious, progression in an operation is to potentially install persistence. So at this point, you've gathered all your credentials you need. You've gathered all the elevated context you need. Now you just need to know how to stay overnight. Just like you would with a Mac, they're often laptops. So persistence turned out to be a really critical thing for us. So on the Windows side, there is so much research out there, and there's so many places to hide. The registry itself, I don't know if anybody truly understands it. There's tons of research on WIMI, DLL hijacks, backdoored accounts, startup folders. There's tons of ways to go about staying. But also on this front, OSX actually surprised us quite a bit. There's a few really popular public, persistence methods out there, mainly because it is, at the end of the day, a NICS device. So you can use cron tabs. They have their own built-in login hooks, daemons, dial-up hijacking. All these can be really used and effective on engagement. The first one I'm going to start with is login hooks. Login hooks are something Mac developers in place. I think it was almost in 10.1 or something of the sort. It's actually technically now deprecated, as in it's unsupported functionality. Some of the reasons why you may not want to use this is the fact that it is blocking. So if you fail, or if your persistence module fails to execute, you could potentially stop the user from logging in. The one reason why this may be successful for you is, let's say you don't have root access yet, maybe staying in user context is the way to go. So in this case, any user or any user on the box can be applied a login hook. Another unfortunate con about this is you can only have one login hook per user. So if that's already being used, you're kind of out of luck. The next thing that Steve actually used quite often was cron tabs. In case you want to beacon every hour, well, you can make that happen, no problem. So same as you would with any other one, you can set up an Apple script, binary, or just even a Bash or Python script, and you can have it execute right from the cron tab itself. Timed execution of payload, and it's great for continued access in case they're restarting consistently or sleeping the box, and in case your agent dies, and there may be bugs out there, so you never know what's going to happen. The next one is launch daemons. This does require root, obviously, but we'll talk about this in a second. There is potential for user context as well. The interesting thing about launch daemons is they're started during system startup before the login prompt is presented, actually. So inetd actually starts these up. They're a plist file that is then taken through key values and executed. So in this case, you basically can set up a couple different cool keys out there. You can basically give it a start interval. You can keep it running. So in case that plist file daemon's actually stopped, it will actually restart itself. Think just like a Windows service in this case. So it'd be like an auto start per se. So that's a really cool benefit of these. And there's also potential for us to move over onto user context side using launch agents. And the cool thing is, as I talked about before, if the system's taxed and login hooks fail, you could potentially lock a user out. With this, it doesn't have that potential con, but it will basically it'll basically launch once the system has enough resources to launch your daemon in that case. So that's quite cool. Obviously, like we talked about before, Packard-Wardle did this great research on the hijacking dilibs. It's something that we've used a few times and I've tested a couple times, but this can also be deployed for a more stealthier version of persistence, of course, but the only obvious concern is that it's only when you start that application is when you're going to get that agent back. So that's something you have to keep in mind. As we talked about before, there's the scanner, but there's also the create hijack module, which actually goes through all the headache of actually generating the module, patching it, and then actually deploying it, overwriting, and creating the secondary pass for the follow-on so the program does launch successfully after you've hijacked the dilib.
So I'll speak just a quick second. I know we're about out of time. Future plans for the project. Everyone's like, well, EmPyre, PowerShell EmPyre, whatever, what does this mean? We're going to combine both code bases within the next few weeks. So we'll have one command and control platform that allows you to attack Windows systems and OS X systems. And we'll have some of those nice bits that Steve talked about passing agents between the two and kind of that cross-platform attack kind of approach. That'll be much, much nicer. We also really want to get SOX pivoting in. That's one of our biggest to-dos. We'll see if Alex stops being lazy and actually finishes all the code. But it's been a really fun project. We've had a blast doing it. The code's been out there for a couple months. It's on GitHub. We forgot to put this up there. GitHub/adaptive threat/EmPyre. If you just search for the project name, you should be able to find it. We also have a large number of blog posts that talk about usage, phishing. We have a ton of documentation on this stuff. So with that, thank you. And are there any questions?
There's one thing I want to note before we get too crazy in the questions. He talked about the fact that it's OS X and Windows. I've actually got to successfully use this on a Linux Red Hat installation, and that's why we actually went back to 2.6. So this is truly not only just OS X and Windows. This can actually be deployed in an agent scenario where you need Linux box.
We use it in cloud environments and everything.
Yes.
What's required on the Linux side? What dependencies?
So the question is, what's required on the Linux side? What dependencies? The core agent is 2.6 compatible, so you need at least Python 2.6. But otherwise, every single component of the core agent depends on the standard Python library, so the standard lib. There's you don't have to install any packages, whatever else. It's everything that's automatically comes with the stock installations for 2.6 and 2.7. Yes.
Can we use Python?
Sorry, what was the question? Actually, can you use the microphone?
We're
real
going to
quick?
use the microphone.
Yeah, sorry.
That's good.
Can you compile your framework with Python?
With Python. Can we compile the framework with Python? I haven't looked into that. Have we touched that yet?
No.
Because we want to keep this you don't have to compile it because it runs on Linux as is. We don't support running on OS X, like launching the server on OS X as well. A lot of people have asked us that. But we keep it as an open framework, haven't compiled it that way.
Yep, so we don't have it now, but if you would like to try to do that pull request, that would be awesome. Yes.
Also, are you aware that you can dump, thinking about your gathering credentials, are you guys aware that you can dump Wi-Fi passwords in plain text? You might want to add that on.
Yeah. And it's actually in the system keychain file. The chain breaker file, actually, the chain breaker module, not the key dump exploitable one. That actually does dump. You can actually pass a specific path for the keychain, and you can actually dump the system keychain and get Wi-Fi passwords.
Yeah, you can actually do it without having to get into the full keychain.
Okay, we should talk out there.
Yeah, we should definitely talk.
Quite interesting.
Any other questions? Just go up to the microphone, please.
Damn.
You mentioned Patrick Ward's stuff. He also wrote Knock Knock, which
Yes.
goes through everything that's in launch agents and all that jazz to show things that are being persistent.
Right. If we're on an engagement, you asked if Knock Knock is installed, right?
I was about to.
Oh, go right ahead.
If Knock Knock's installed, does it show up your shit?
Yes.
Cool.
Knock Knock will show the persistence modules that we have currently.
Yep.
If we're on an engagement and Knock Knock is installed, maybe we disable it first. If we have the access to do so.
I mean, how is Knock Knock installed? It's just
Right, we'll get rid of it or remove it or hide it for the time being. It depends if you're on a red team or what your scope is. What can you do on that?
Do you have ways of evading this?
If Knock Knock is run with the persistence installed, it will detect it.
I guess at the end of the day, you just have to
Mostly, I wanna
find a
know
new
how
method.
to avoid Knock Knock.
Yeah.
Oh,
Yeah. Oh, okay.
We do too.
Yeah.
I guess at the end of the day, you have to develop something that's not in
let's
his
talk
tool
about
set.
it. Great.
Thanks.
Thank you.
On the Linux side, a lot of stuff you showed was capturing the passwords.
Yep.
What modules do you have for similar on the Linux side?
So the question is, what types of modules do we have on the Linux side? So the framework was originally built for a couple of clients and engagements that were OS X specific. So that was where our focus was to kind of get everything done. We really want to expand the Linux side instead of just the OS X side. And
Most of the stuff's OS X.
sorry?
Most of the stuff's OS X.
The majority of it is OS X, but one of our goals in the next few months is to expand the Linux post-exploitation. For example, if you stay in this room for the next presentation, I believe they're dropping some Linux type OS X post-exploitation modules that I'm hoping they'll do a pull request in the next few weeks.
Yeah, I think we have 4 modules right now. Just to quickly list them off, we have the hash dump pillage user, the Linux PrivX checker and the Unix PrivX checker, and also a pure in-memory PCAP sniffer.
Yep. Yes.
You guys mentioned you're looking at different CNC methods. I'm wondering if that's something, like A, what you're looking into, and B, if that's something you've had a hard time with, or if you find that HTTP usually works and it's not a problem.
Yeah, so one of our goals with both the first thing, the next week, we want to combine PowerShell EmPyre and Python EmPyre into one framework. And after that, one of the goals right after that is to expand and modularize the command and control components for both projects. So we want to build the architecture that you could easily build a module to drop in. Cool. Yeah. All right. I think that's about it. We'll be out here for about 10, 20 minutes if you guys want to have a few more questions. Thank you.
Thank you.